So now let us look at what we have already learnt. We have learnt that if I throw this ball horizontally and I drop this ball, both balls will take the same time to hit the ground. So when this guy hits the ground, this also hits the ground. But we only learnt about this as if it hits the ground. So now we are going to extend that idea. So let us say that I threw this ball horizontally and I dropped this ball. So I'm going to use another ball to show you that I have dropped this ball. The thing is that this guy takes so much time to hit the ground. You know already that the time it takes to hit the ground must be the same as the time this fellow takes to hit the ground. So if this takes 4 seconds to hit the ground, that will also take 4 seconds to hit the ground. So this we already know. But where is this ball after 2 seconds? After 2 seconds, let us say that this ball is here. Where will this ball be after 2 seconds? Turns out that it will be exactly here. Why? Because the ball does not know that the ground is here. So you could have kept the ground here. If I had kept the ground here, would they have hit the ground at the same time? Yes, right? It's the same idea. But it would have hit the ground at 2 seconds. So if this guy comes here after 2 seconds, that fellow must be at the same level after 2 seconds. Because I could put the ground, but I don't have to. Suppose I removed the ground now. The ball cannot say, oh, there is the ground, so I will come faster. There is no ground, I will come slower. No, it won't make that decision, right? So the ball is going to move the same way whether there is a ground or not. But if I kept the ground here, it has to hit at the same time. So which means when this ball is here, that ball is also there. More generally, what does that tell you? That tells you whenever this ball is at this level, that ball is at the same level, right? This ball and this ball are always at the same height. So everything about this ball is repeated in that ball vertically. It also says something more. For example, if this ball here has a velocity 20 meters per second downwards, and this guy had a starting velocity of 7 meters per second, at this point, 2 seconds later, this ball will have a velocity of 20 meters per second downwards. Plus, it will also have a velocity of 7 meters per second. The velocities are the same. Why should the velocities be the same? Because it is moving the same amount in the same time. So at this point, if it was 20 and that was 30, that is moving more, faster. But it is not, right? They're all coming down the same amount vertically. So that is only possible every instant that happens. That's only possible if they both have the exact same velocity. Because you can say, let's go from here to there, a very small amount of distance, vertical distance, in the same amount of time, and then you can calculate the average velocity and you can make this distance very small. So you'll find that the instantaneous velocity here and the velocity there, vertical components, will be exactly equal. Now that's very, very useful to keep in mind that their vertical velocities will be equal, the vertical displacements will be equal at every instant. Okay, now we can similarly analyze the same idea for a horizontal ball. I call this the vertical ghost ball. So this is the vertical ghost ball. So this is the vertical ghost ball. And now let us look at the horizontal ghost ball. Ghost ball because it's not real. I'm just imagining this ball. Okay. So if I look at this ball moves like that. In 4 seconds, this ball is just above that ball. Right? But in 2 seconds, when this ball is here, that ball will be there. Okay? In 1 second, it should be there. I have not drawn it properly. But the basic idea is wherever this ball goes, exactly below that ball will be. Now let us consider a slightly different situation. I have here this ball thrown with 7 meters per second. Now imagine not this ball, but another ball which has no gravitational influence. So I will call this the horizontal ghost ball. Okay, because it's not a real ball. So imagine this ball and that ball both with the same velocity, 7 meters per second. So after 1 second, where will this ball be? Here. Where should this ball be? This fellow feels gravitational influence, so I will put a G here. So where should this fellow be? You already know that it should be right there, right below that, but it won't be there because it is getting pulled down, but its horizontal motion has not got affected. So it is going to be here. It won't be here. It is going to be there. This is where it should have been, but it got pulled down because of gravity. Right? One more second later, when this fellow gets to that place, this fellow should be right below. But right below where? Somewhere there. Is that idea clear? So this ball, the way that horizontal ghost ball, which does not have gravity at all, that ball, the way it's moving, this ball is right below that ball. We have already seen this. You can combine this with the earlier idea that this guy's vertical position is the same as the vertical ghost ball. So now let me combine the two ideas together. The first point I want you to keep in mind is wherever the horizontal ball is, right below that must be this real ball. Wherever the vertical ball is, so for example, if I draw the vertical ball here, wherever the vertical ball is, right at that level, the actual ball must be. So when the vertical ball is here, the actual ball must be there, right? So let us see how we can therefore combine this and that together to get the actual projectile path. So now let us imagine this ball that was thrown, let us say now with 5 meters per second. I am going to now think of two balls. One is the horizontal ghost ball that I will draw here. So this is also moving at 5 meters per second, has no gravity at all, but only has a horizontal velocity. And then I will also take another ball here, and let's say that this fellow was dropped 0 meters per second. No vertical, it has a vertical velocity of 0, but it is going to move vertically, but has no horizontal motion. Okay. Now 1 second later, where is this ball? 1 second later, this ball is going to be there. This is after 1 second. 1 second later, where is this ball? The vertical ball. This ball would have fallen like this, right? So 1 second later, it's going to be somewhere here. Clear? So this ball has moved this much, this ball has moved so much. In fact, it would not have moved so much, it would have moved lesser, let's say that much. Now, where is this ball going to be? It is going to be at this level. It has to be the same level as the vertical ball, and it has to be the same horizontal displacement as this horizontal ball. This is where it has to be. So this fellow would have moved like that. Is the idea clear? Now, if I continue and say 1 more second later, where is this guy? There. So this is 2 seconds. 1 more second. So this is 1 second, right? 1 more second later, where will this be? This is already now faster, because 1 second later, this guy has a velocity of 10 meters per second. And this will also have a velocity of 10 meters per second, like that. And here this fellow has 5 meters per second, right? This fellow will also have 5 meters per second that way. It has 10 meters per second down and 5 meters per second like that. So because this was starting at 0 and ending at 10, it was moving so much. But now it's starting at 10, it's already faster. So it's going to move this much. So this is 2 seconds. It has moved a lot more than in the first 1 second. And at this point, its velocity is 20 meters per second. Every second you increase by 10 meters per second. Now, this is the point where, this is the level where this ball should also be. But then, this ball is not here. It is not going to come down here. It is not here. It must be vertically below that. So, that's where the ball should be. I hope that is clear. So, this is the new position of the actual ball. So, this is the actual ball. This one is the horizontal ghost ball. This is the vertical ghost ball. Okay. Ghost is just to say that these are not real balls. Okay. So this is the real ball, and so this is how it is moving. Can you see what's happening? And then in the 3rd second, this will go down a lot. But this guy will move horizontally only the same amount. So then you draw this line. And then you say, well, this is so far below. So this guy will come and end up there. So that's how we will calculate. Let me not worry about it right now. What I'm more interested is, at this point, this ball has a vertical velocity of 20 meters per second. This guy has 20 meters per second. This fellow has 20 meters per second vertical velocity. Plus, in addition, it has 5 meters per second horizontal. Notice that the horizontal velocity is not changing at all. The vertical velocity is constantly increasing at uniform acceleration. So I hope this idea is clear to everybody, right? So basic logic of this is that you can think of this projectile path as a combination of vertical motion and horizontal motion. So earlier when we were doing questions, all the problems that we did, it always hits the ground, right? So if it hits the ground, that means you know that this is the position where it hits the ground. So you use the vertical motion to calculate the time. But now what we are going to do is to look at cases where it doesn't hit the ground, it can hit a wall. In which case then you'll have to think a little bit more. So let us look at a few examples like that. So what have we learned with this example? Basic idea is that it is not about hitting the ground. At every instant, anywhere in the middle as well, you can think of this ball as if it was a combination of a horizontal ball and a vertical ball. The vertical ball, whatever velocity it has, this ball will also have. Whatever displacement the vertical ball has, this will also have vertically. And then you can say that it also has in addition a horizontal displacement, a horizontal velocity which matches the horizontal ghost ball. So we usually say we can take this projectile motion and split it up into a vertical motion and a horizontal motion. So I can think of this projectile as moving down so much and then moving to the right or moving horizontally so much. Or you can think of it as moving horizontally so much and moving vertically so much. This is independent of that. This is the same as this problem, but this problem you already know how to solve. So we will use this problem solution to solve that. And then for the horizontal motion, because it's uniform velocity, we will use Vt is displacement to calculate that. So somebody says, what is the displacement of this ball? The displacement is a vector from the beginning to end. You can say the displacement is equal to this vertical displacement plus this horizontal displacement. This vertical displacement you can calculate from the ball that has been dropped. The horizontal displacement you can calculate using S is equal to Vt. So the basic idea is that projectile motion is nothing but a combination of a horizontal motion and a vertical motion. Two things are completely independent. The vertical motion is uniformly accelerated like a free fall, regular free fall drop, right? This is also free fall, but that is straight line free fall motion. And the horizontal motion is very simple, it is uniform velocity. Okay, so now let us learn how to combine this with slightly different types of situations where the same principle will work, but because the situation changes, the conditions change. Now let's imagine a situation where from one building you are throwing a ball, you are throwing two balls, A and B. From the same place, both you are throwing horizontally, like that. Okay. Now A you are throwing at 5 meters per second and B you are throwing at 3 meters per second. Now A goes and hits the ground there. So that is A. Will B hit it closer or further away to the base? Well, B was moving at 3 meters per second. That is 5. So that is faster. So that is going to go there. Whereas B is going to go and hit the ground somewhere here. So this is B. Now what you know is that this distance between A and B, the distance between A and B is known. And let us say that that was 6 meters. And somebody is saying, hey, tell me the height of this building. How will I calculate height of the building? Very simple. You know that A would have taken some time t to hit the ground. Will B take more time, less time, or the same time? Same time, because from the same level, horizontal throw, so B will also take t seconds. But for all this time that A was traveling, it was traveling constant velocity of 5 meters per second. So A would have traveled how much? From here to there, how much? 5 into t. A would have traveled 5t meters. And how much distance would B have traveled? 3t, exactly. So it would have traveled 3t meters. So what is this extra? 5t minus 3t is 2t. 2t is this distance. That is 6 meters. So what should t be? 3 seconds. So you know that it must have taken 3 seconds. You can also calculate that very easily by saying, in the first second, this guy would have moved 5, this guy would have moved 3. Don't worry about the vertical motion, because in 1 second when this fellow is here, this fellow is here, they are both at the same level. these two must be both at the same level. Why? Because they would have come down by the same amount, but they are at two different points. This is after 1 second. In 1 second, what is the distance between them? This guy would have moved 5, this guy would have moved 3, 2 meters. One more second later, this guy would have been there, this fellow will be here, same level, but this distance will become 2 plus 2, 4. 3 seconds, it would have become 6. Okay, so I hope you think about this, you will get the idea. So this ball was moving for how long? 3 seconds. So this is 3 seconds. If I drop the ball, how much time will it take to hit the ground? 3 seconds. But if it drops, then you know that this is 0. You know that this distance must be 5 into t square, 5 into 3 into 3, that is 9 into 5, 45 meters. So the height of the building must be 45 meters. So just by knowing what the distance between the two objects are when they hit the ground, you know this distance, you can calculate the height of the building. So this is a very nice and powerful way of solving or using projectile principles that we have learnt. Now, in all these questions, I have used the idea that it always hits the ground, therefore time is calculated from the time it takes to hit the ground. But now let us look at a situation where you have a wall, maybe something that is blocking it, so these fellows go and hit the wall. So let us think about a question like that. Now let us look at another situation. I am throwing this ball and the ground is here, but then there is a building here, a wall or a building, let us say another building. So now when I throw this ball, there are many different ways many different things it can do. If I throw it at a very low speed, it could come like that. I could throw it like this with a little faster velocity. Now let us say that this was 2 meters per second, this was 3 meters per second. What will be the time when it is 2 meters per second? Suppose this time, let's say this was 45 meters. Suppose this was 45 meters. Then when I'm throwing it at 2 meters per second, how much time will it take to hit the ground? You know 45 is 5t square, we have already calculated this. So t must be equal to 3 seconds. So it takes 3 seconds to hit the ground. When I throw it at 3 meters per second, it still takes 3 seconds to hit the ground. Right? What is this distance? 3 meters per second into 3 seconds. So this must be how much? 9 meters. And how much must this distance be? 2 meters per second into 3 seconds. So this must be 6 meters. Suppose I make this 4 meters per second. It is going to go like that, and let us say it just hits the bottom of the building. So this is 3 seconds. Right? It still takes 3 seconds because it takes that much time to hit the ground. Now, how much would that distance be? This distance would be 12 meters. But now suppose I hit it at 5 meters per second. I throw it at 5 meters per second. What do you think it will do? It is going to travel like that, and it is going to hit the building there. Do you understand that it is not getting to the bottom of the building? It has hit the building there. Is that understood? Clear? So, this travel time is not equal to 3 seconds. Will it be more than 3 seconds or less than 3 seconds? It has to be less than 3 seconds. Because if there was no building, this would have come and hit here, and that would have been 3 seconds. So, this will be less than 3 seconds. Now, how do I find out what that velocity is? In fact, let me say that this guy was thrown at 6 meters per second. Instead of 5 meters per second, let me say it was thrown at 6 meters per second, and that's what comes and lands up here. I want to know this time. I cannot use 5t square is 45 because it did not fall 45 meters. In fact, not only that, I also want to know this distance. How far has it fallen? What do we do? Well, you know that it is moving at 6 meters per second. What is this horizontal distance? 12 meters, it's given. So if you know this is 12 meters, this is 12 meters, it is moving at 6 meters per second, how much time should it have taken? 2 seconds. Because 6 meters per second into 2 would give me 12. So this takes 2 seconds. But if it took 2 seconds, this height is 5 into 2 square. So 5 into 4, 20 meters. If instead of the 6 meters per second, I had made it 5 meters per second, so let us say it was 5 meters per second, then it would have come like that and hit the ground here. not the ground, it would have hit the wall here. Okay. Now, why am I saying there? Because it was slower, it is going to keep moving less. How much time will it take to reach this place? 12, it is going to, because this distance is still 12. But it's moving at what speed? 5 meters per second. So therefore, it will take 12 meters by 5 meters per second, which is 2.4 seconds. So it will hit this place at t equals 2.4 seconds. So is it going to hit the wall or is it going to hit the ground? That depends on whichever time is less. To hit the wall, right now, for example, if this guy has to hit the wall, imagine, this will never hit the wall because by the time it will already hit the ground. To hit the wall, it will take you more time because this is 12 divided by 3. 12 by 3 is 4 seconds. So it will take 4 seconds. If the wall was deeper like that, it will go and hit there after 4 seconds. But before that, 3 seconds, it's already hit the ground. So it first hits the ground. Whereas this guy, before it can touch the ground, it has already hit the wall. Because to hit the ground, it would have taken 3 seconds, but this guy is already hitting the wall at 2.4 seconds. So whatever is going to be hit first, that's what you should use the time calculation for. So you use horizontal motion. If you knew the horizontal displacement, you can use horizontal motion to calculate the time. Many times you know only the vertical motion because you know the height. So you know where it's going to, you don't know where exactly it's going to hit the ground, but you know it's going to hit the ground. So you know the height. You don't know the horizontal displacement. So here I use the height to calculate the time. Then I use the time to calculate the horizontal displacement. Whereas here I use the horizontal displacement to calculate the time. Then I use the time to calculate the height. Is that understood? If you use the horizontal motion to calculate time, you can use the time to calculate vertical displacement. If you use the vertical motion to calculate the time, you should use the time to calculate the horizontal displacement. Now what happens in each situation, you'll have to think hard and then decide. Whichever it hits first, that is basically what will decide the time. So you have to make up your mind on whether it's going to hit the wall or the ground by doing the calculation. Assume ground, you know that's 3 seconds, hits the wall 2 seconds, what do you think will happen? It will hit the wall. Because to reach the ground it takes 3 seconds. So before that it has already hit the wall. So after it hits the wall, it's not going to continue, it is going to bounce like that. Okay, now there is a small trick. If the bouncing happened elastically, then this vertical velocity is not affected at all. So whatever it was doing, it will continue to do. So the vertical motion does not change. So which means it will go hit and it will come back. And how much time will it take to finally reach the ground? 3 seconds. Because nothing has happened to the vertical motion. That's a small trick involved, assuming it is a smooth wall and elastic collision. Okay. In fact, if it is a smooth wall and there is no forces acting in the vertical direction, then there are no changes in the vertical direction. So vertical velocity remains constant. So it will come down as if nothing had happened vertically. So it will take still the same time to hit the ground. Okay. But you can also do some more stuff if it was elastic, because you know that horizontal velocity will just simply get rebounded. And so you know the velocity will be in this direction. You can use that to calculate where it hits. But those are slightly more complex questions. We'll come to that little later. At this point, what I want you to understand is if I throw, you have to know whether it's going to hit the wall or it's going to hit the ground. Now you can combine questions where you have two objects thrown, but it might hit the wall or it might hit the ground. You have to calculate. If it hits the ground, remember, when it hits the ground, if I threw 2 objects, you calculated the distance and that gave you the time and that gave us the height. If it's going to hit a wall, then the first fellow is going to go and hit that, the second fellow is going to go and hit this. The time is not the same. The time is not the same. Why? Because when this ball, the first ball, let's say faster ball was here, the slower ball is here, right? So that means at this time, so suppose I tell you this is 2 seconds, this is 2 seconds. So this will be more than 2 seconds. So this will be more than 2 seconds. So you cannot say times are the same. Here of course you can say times are the same. Here you can say I can find this time, I can find that time, and then you can find this height difference. So little bit more messy, more complex. But hopefully this is clear. You can apply this idea and combine it with a question where you have 2 balls thrown. You should be able to use it together. So I hope this is clear to everybody. So we have learnt that it is not just the fact that objects hit the ground at the same time. Every instant, the vertical motion of an object which is thrown horizontally and an object that is dropped, the vertical motions are identical. Their velocities are identical, their vertical displacements are identical. Similarly, the horizontal motion for a zero gravity ball and the horizontal motion for a ball with gravity, the horizontal velocities, then horizontal displacements are identical. And that becomes the essence of solving projectile problems. Separate the problem into a horizontal motion question and a vertical motion question. The vertical motion questions you can solve by saying it is the same as a ball that is dropped. So uniform accelerated motion. The horizontal questions you can solve by saying it is exactly the same as a uniform motion question. So that's very, very easy to solve. You can solve it directly. So I hope that is clear. So combine this with a whole bunch of problems, work them out, because the best way to learn and understand projectile motion is to solve a large number of questions.